just to remind ourselves. You don't have to draw this. I do because I ran out of room. Am I correct? Okay. Now, in math, you know how you might say x times x? Well, what could you really just say? Okay, x squared. Good. We got that from algebra, right? Okay, so we're going to say instead of p times p, we're just going to say p squared plus p cubed, but there's two of them, 2pq, plus this q squared right there. And we said the sum of all of these guys would have to be equal to 100%, which would be the number 1.0, changing that into decimal form. Right? What you're seeing right here is an equation we're going to use probably for the rest of today, and the name of that equation is, does anyone know? Hardy-Weinberg equation. I promise you this will be on the AP exam. The Hardy-Weinberg equation. Cool. Now, what was the p squared part referring to? This little guy right there. The homozygous dominant individuals. What was the 2pq part referring to? Heterozygotes. And what was the q squared part? Right. Good. What would you call this? This is like is this a trinomial? I don't know. I don't know the names of it in math. Does anyone know the name of this type of a statement where you have x squared plus 2xy plus y squared is equal to some number? Nobody knows? Okay, it doesn't matter then. Let me ask you to do a math question for me. Let's just pretend this is p's and q's still, only just like variables. I want you to take this and I want you to factor this off to the side. So I want you to take this problem that you see, and I want you to factor it. I'm going to give you 7 seconds to factor it out. Do not use a TI-89 and hit the solve button. Okay, did we get it factored? We should have gotten something like this. P plus Q times P plus Q is equal to 1. Is that what y'all got? Okay. Now, isn't this just like saying P plus Q squared is equal to 1? Agreed? How would I solve for my variables? Well, to me the next step would be to take the root of it, right? So let's do the root of both sides. So then we have 1 is equal to P plus Q. I think that's about all we can do. Now let's remind ourselves from my previous page, it might still be on your same page, I'm not too sure, but can you tell me what does P represent, the variable P? Okay, so P was referring to your dominant allele, and Q was referring to your recessive allele. So in a system with two alleles, big T and little t, or we're calling them P and Q, the addition, the sum of those allele percentages would have to be equal to, again, your 100%. Let's say that 90% of the population of humans had the normal sickle cell trait, which means they were big T, they were fine. Well, then that would be 0.9 right there. What is the Q value? 0.1. What do we think? Good? We want to talk about it?
So what happens when you have more than this? Like, if you have something that's like codominant, does not mess up.
And you know what messes it up more so is the fact that there's really not many human traits that are big T than a little t. Most of our stuff has multiple alleles, which means this equation in reality, this is the equation for like Mendel's pea plants, but the equations for humans are like extremely large. Me?
That's a question.
No. Good. Let's look at some example problems.